Hi everyone, in this video I'm going to sneak in a little bit more functions review, some composition and inverses stuff in particular, a little bit of transformations I'll mention, but I did make sure to include part of a circle as one of my functions. So let's just look really quickly at what we're actually working with these two, and then we can check the composition and the inverse. This first one, I'm hoping you're starting to recognize that that is half of a circle. So I'm looking at y equals square root of 9 minus x squared, which means that y squared is equal to 9 minus x squared. Square both sides, which means that x squared plus y squared is equal to 9. So it looks like we've got a circle centered at the origin with radius 3, or if you need to do another step or two, you can divide out that 9 equals 1. And there again, I'm seeing circle centered at the origin with radius 3. So going back to what I started with, I had y equals a positive root. So I've actually only got the top half of my circle, which is a good thing when we're talking about functions. An entire circle is a great relation. It's a lovely curve, but it is not a function. It doesn't pass a vertical line test. So by only looking at the top half of this circle, we do in fact have a function. But we have to be careful because there's even more to it than that. Not only am I only seeing the top half because it's a positive root, my x's have been restricted to only be from -3 to 3. So really all I'm getting is a quarter of a circle. Okay, so that's what my f of x looks like. I don't think we need the graph of g, but just to mention it, again, good transformations review. If we're looking for the graph of g, we would start with a basic square root function. And I see vertical flip, so flip over the x-axis. And then I see shift to the left by 9. So it's going to move quite a ways out this direction. So this is -9, 0. Okay, so that's what our g of x function would look like. Really rough sketch. Okay, so first, let's go ahead and find f of g of x. So if we want f of g of x, we're going to take function g of x, which is negative square root of x plus 9, and we're going to plug it into function f, which is going to give us the square root of 9 minus our input squared. See if I can not run into that top stuff. Okay, so some nice things happen. When you square this, you're multiplying a negative square root x plus 9 by another negative square root x plus 9. So the negatives will cancel out. And then the square root multiplied by itself will actually wipe out the square root as well. So I end up with a square root of 9 minus x plus 9. It's really important that you keep those grouping symbols. The square root was a grouping symbol, so it grouped the x plus 9 just like parentheses would, which means when it goes away, you are no longer supposed to square root, but those two should still be grouped, so the negative applies to both. So I have a square root of 9 minus x minus 9, which means that f of g of x is equal to the square root of opposite of x. Opposite's a really good way to say that because if you say negative x, it really gets at something that people worry about. That looks like it shouldn't be legal to a lot of people, but it is. Excuse me, God. The deal would just be that you can only plug in negative x's because if you start with a negative x, when you take the opposite, it will be positive, which means you'll be able to square root it. Okay. The second part of this is find f inverse. So the algebra is nothing too terrible. It's similar to what we did up above. So we'll switch our x and our y. And then we'll solve for y. So for starters, we'll square both sides. Wipe out the square root. Then we're solving for y. Let's go ahead and subtract 9. X squared minus 9 equals negative y squared. And I'd like to get rid of the negative sign. So be careful about your order of operations here. We have one y over here by itself. So you want a reverse order of operations to solve. So I see if I plugged in a number here, the first thing I do would square. The first thing I would do is square it. I would then subtract it from 9, or you could think about that as multiply by -1 and add 9. I don't know if that sounds better or worse. And then square root it. So the first thing we got rid of was the square rooting. The next thing we want to get rid of is the adding 9, which is why I said it in that confusing way. Then we want to get rid of the multiplication by -1. So we'll multiply both sides or divide both sides by a -1. And I don't love the order on that, so I'm just going to do a quick flip-flop. I'm going to say 9 minus x squared equals y squared. And then we can square root both sides. So we get plus or minus the square root of 9 minus x squared equals y, which interestingly is exactly what we started with for f, other than the plus or minus part of that. So we're going to have to make a couple of decisions. We've already said that when we're looking at a circle, it has to pass a vertical and a horizontal line test. So a quarter of a circle, I don't know if I actually already did say this. I'm saying it now. A quarter of a circle is going to be about as much as we can do. If we do any more than what fits in a single quadrant, we're either going to fail the vertical or the horizontal line test. So to decide on the plus or minus part, so this is the top or the bottom half of the circle, I'm going to go back up to my graph. I'll show you how to look at domain and range to do this as well. But remember, if you want to get the graph of an inverse, you just flip your function over y equals x. So if I flip this across, I'm looking for the part of the circle that's in quadrant 4. So this tells me, for starters, that I should choose the negative root. So I'm going to say over here that f inverse should be a negative square root of 9 minus x squared. But I actually have to do even a little more than that. If I just leave it there, I'm getting the entire bottom of the circle, and I don't want the entire bottom of the circle. I only want the part between 0 and 3, so I have to actually tack on a domain restriction as well. So just like we had to tack on a domain restriction for the inner function, the initial function, whatever we're saying here, this f of x, the reason we had that restriction was to make it 1 to 1. We have to do the same thing for this final function. You could also do this by using domain and range. So if we look back up at f, the domain was -3 to 0, and the range was 0 to 3. So, me and my not lining up the paper, sorry, there you go. Domain -3, 0, range 0 to 3. So that means that for the inverse, the domain should be 0 to 3, and the range should be -3, 0. So the fact that I'm only getting 0 or a negative number for my y's tells me it's the bottom half once again, so that would choose the negative for me. And then this, if you're not thinking carefully about the graph, you might not realize that you have to specify this. This function right here, again, without the restriction, would allow you to have any x between -3 and 3. And we don't want all of that. We don't want the whole bottom. So either way, you should be able to get a domain restriction on that, as well as choose your plus or minus. All right, thanks for watching.